Hi guys. In this video, we are going to discuss the quadratic function, which is otherwise known as the parabola. And for the parabola, it's most recognized by being this U-shaped curve on our Cartesian plane. And as always, we're going to start with the base equation, which I covered in my last video. The parabola always takes on the form of y is equal to ax squared plus bx plus c. Now remember, in grade 10, we are going to set the b value to 0. So our standard form for the parabola at grade 10 level will be y is equal to ax squared plus c. Now, similar to our straight line graph, we have our y value and our x value that represent our Cartesian plane axes. The a and the c values affect the graph in various ways, and we are going to study exactly how they affect the graph. The c value, which is identical to our straight line c value, represents the y-intercept, where the graph cuts the y-axis. The a value for our parabola is what I like to call the spread. And this value directly impacts how far apart these arms are going to travel away from each other. The bigger the a value, the wider apart the arms will be. But more importantly, the a value describes the orientation of our curve. If a is greater than 0, in other words, if a is positive, our graph takes on a smiley face shape on our Cartesian plane. And on the other hand, if a is less than 0, which means it is negative, our graph will take on an upside down shape. Now, let's focus on how to actually plot a quadratic function on a set of axes. Now, we are interested, for all parabolas, on 4 main points. Two of these points are our x-intercepts. Remember, most parabolas will always cut the x-axis at 2 specific points. Another point is known as the turning point, which represents where the graph changes a complete direction. In other words, that would be a turning point. That would be another turning point. And the next point that we're interested in is our y-intercept. Now, the great thing about this equation at grade 10 level, because there is no b value, our turning point and our y-intercept will always fall exactly on the same point. So in other words, we actually need 3 points to plot this graph on our Cartesian plane. 2 x-intercepts and our turning point or y-intercept, which is the same thing. Over here, I'll have a quick example. So I've used the example of y is equal to 2x squared minus 8. Remember, our base equation looks like this. And I'm going to rewrite this into functional notation when referring to it on a Cartesian plane. And remember I said that there's 4 points of interest. Well, let's turn that into 3 points of interest, namely our x-intercepts and the y-intercept, or our turning points. Let's go ahead and find our x-intercepts. And our x-intercepts are found using the exact same method as our straight line graph, where we set the y value to 0. Therefore, the equation will read 0 is equal to 2x squared minus 8. And I'm going to go ahead and use basic algebra techniques to solve for x. You could probably apply the dots method to this equation, which is probably a bit more efficient. But I'm just going to stick to the basics. I'm going to take the negative 8 over, which reads 8 is equal to 2x squared. Then I'm going to divide both sides by 2 to get the x squared by itself. 8 divided by 2 will be 4. And I'll be left with that. Now I need to square root both sides to get x by itself, where x is equal to the square root of 4. Now this is where most people get it wrong. The square root of 4 is 2 and negative 2. Therefore x is equal to 2 and x is equal to negative 2. And this will produce the coordinates 2 and 0 and negative 2 and 0. Now that we have our 2 points, we need our third point, which is known as our y-intercept, or our turning point in this case. Remember, because of the nature of this equation, our parabola will always be symmetrical about the y-axis. And the way to get the y-intercept is really simple. It is identical as to how we obtained it in our straight line equation, where we set x is equal to 0. So we're going to go ahead and say that our y-intercept is that c value, which is negative 8, which also represents our turning point. So I'm going to go ahead and mark those on our Cartesian planes. That would be 2 and 0, negative 2 and 0, 2 and 0, 0 and negative 8. Now the parabola is a bit tricky to plot because of the fact that it's a curve, and it's not as easy as a straight line where you would just use your ruler. So you could probably plot a whole bunch of other points to make it a bit more accurate in nature. So we could start subbing in random values for x to get a better idea of what this curve actually looks like. But for the most part, I'm just going to try my best to actually plot this, and our parabola will look something like this. Where it cuts the y-axis at 0 and negative 8. And this would be the graph of f of x. Please note that because our a value was positive, it takes on the shape of a smiley face curve. If this was a negative, it would be upside down. I thank you for watching this video. In my next video, I would like to cover more properties about the straight line and the parabola, so please stay tuned.